Hi, welcome to another junior geometry video. We're going to chat about symmetry. Now, symmetry in a 2D or two-dimensional polygon is made up of two parts. The first part of symmetry is called line symmetry, and this is how many mirror lines or axes of symmetry there are. The second part of symmetry is called rotational symmetry. Now, this is how many times can an object rotate onto itself in one full turn. How many times can an object rotate onto itself in one full turn? We're going to look at both of these types of symmetry with some examples. But before we do that, let's just talk also about the total order of symmetry. And the total order of symmetry is equal to the line symmetry plus the rotational symmetry. All right, let's get into GeoGebra and show you this with some examples. So we've got four shapes, four examples to look at. Here is shape 1. It's an equilateral triangle. First of all, let's show you how many mirror lines. Because it's all equal, all sides are identical, it's 60 degrees in each angle, and you should figure out there's three sides, there's three mirror lines in the shape. So three mirror lines, one straight down and two on an angle. So three mirror lines. So it's got a line symmetry of 3. Now, let's talk about this rotational symmetry. What we're going to do is rotate the object. Keep an eye on point H. So point H moves, and we're going to rotate the whole shape until it gets back to the start, and we're going to count how many times does it map onto itself as we rotate it. So as we rotate, you'll see that it looks the same there, but we've only rotated it a third. So that's one, rotational symmetry 1. Let's keep going. We're rotating it around and we're going to get to here. So here it's got a rotational symmetry of 2 at that point. And we're not finished yet because H dash is not back at the start. We're going to keep rotating around and we're going to get back to the start. It's got a rotational symmetry of 3. So an equilateral triangle has a rotational symmetry of 3. It's also got a line symmetry of 3. So the total order of symmetry is 3 plus 3, which is 6. Right, let's move on to shape 2. Shape 2 is a square. Hopefully you can figure out this a little quicker because its four sides are equal and all angles inside are equal. There are 4 mirror lines. There are the 4, one straight down, one straight across, and 2 diagonal. Right, let's start this rotation. So keep an eye on point L as we rotate. We've got to get L dash back to the start, and we're counting how many times does it look the same as it moves around. So it's going to look the same once there, twice there, 3 times there, and we're back at the start. So that's 4 times. So it looks the same 4 times as we rotated around. So it's got a rotational symmetry of 4. So the line symmetry is 4, the rotational symmetry is 4, the total order of symmetry is 8. Right, what about an isosceles triangle? Let's do this. An isosceles triangle only has one mirror line, straight down the middle. There's no ones on angles or diagonals. One mirror line, so line symmetry is 1. Now, let's do our rotation. Keep an eye on point R. When we get around to this point here, it doesn't look the same. So no, still, when it's upside down, no. When it gets to here, it doesn't look the same. The only point it looks the same is back at the start, which means it's got a rotational symmetry of just 1. So the line symmetry is 1, the rotational symmetry is 1, the total order of symmetry is 2 for that shape. Right, last shape is a rectangle. Rectangle's only got 2 mirror lines, straight down and straight across. There's no mirror lines on the diagonal. And let's count it as we go around. So let's count as we go around. It looks the same once there, and it looks the same twice back at the start. So a rotational symmetry of 2, total order of symmetry is 4. Right, well that's our video on symmetry, so thanks so much for watching.